Earthblock International's high-speed mobile block machine holds the solution for low-cost housing worldwide. This unit with its dual molds is the first of its kind. No other block machine in the world is capable of using low hydraulic pressure to achieve high hydraulic compression. This is accomplished by the use of our worldwide patented leverage system, which increases the hydraulic compression sevenfold. Because of this, our Earthblock machine does not have the chronic breakdown problems that plague all other high-pressure direct ram machines. Our Earthblock unit can be powered with gasoline, diesel fuel, or with electric. This on-the-spot block factory minimizes the cost of construction as the raw material to build the houses is extracted at the building site. There is no transportation required for transporting blocks, which reduces the cost of building even more. We'll now demonstrate how we take regular soil, turn it into blocks, and build a house. First, raw earth, free of bacteria, is dumped into the hopper of our screening pulverizing unit. This unit processes up to 40 cubic yards per hour, enough soil to supply 4 block machines. As the soil is pulverized into smaller particles, which allows for a more uniform block, a conveyor carries the pulverized soil forward to where water is added. 2 requirements for good blocks are a clay content of at least 10% and a moisture content of approximately the same amount. If the soil has a high sand content, the addition of 2 to 3% cement will hold the block together. As soon as the soil is loaded into the hopper, the blocks are made instantaneously at a rate of 1 block every 3½ seconds. Any excess soil that is ejected from the mold is later recycled back into the hopper. With the machine's dual molds, the unit can produce up to 1,200 blocks per hour. The blocks are 12 inches long, 8 inches wide, and 4 inches high. Each block weighs approximately 28 pounds. Our patented leverage system compresses blocks and delivers them simultaneously from both the right and left mold of the unit. Earth blocks can be dry stacked for future use or can be taken directly from the machine to build the vertical walls of a structure. In this particular case, the blocks are being produced in a nearby field and then transported to the building site. The reason being, the house to be built is adjacent to an existing building and there's a scarcity of soil. When blocks are produced at the building site, it eliminates the need of costly transportation. The blocks can be used immediately for construction as no curing time is required. However, it is important to keep the blocks dry until they are sealed. This eliminates the danger of moisture penetration. Earthblock International has a proprietary one-step sealant and paint application, which can be either rolled or sprayed onto the finished walls. Once the blocks are stacked on a pallet, they can be easily transported by a forklift to any location, or they can be warehoused for future use. Here we see the pallets being loaded on a trailer to be delivered to the building site. Because of the extreme climate conditions where this house is being built, the foundation will consist of a concrete slab and footers. In many emerging nations, however, where the climate is extremely dry, the blocks can be placed right on the ground for building a structure, providing the ground is properly compacted. Those stacks of blocks are enough to build the exterior walls of this house being constructed. Our Earthblock machine makes enough blocks in a 10-hour period to build 2 45-square-meter houses per day. Skilled labor is not required to build an Earthblock house. What is required is a simple string line and a level to keep the rows of blocks straight. The blocks are always stacked oblong to give the walls more stability. They can be either dry stacked or bonded with a mortar of either concrete or mud. When dry stacking blocks, a water mist is sprayed on the surface of the blocks, causing them to seize together and form a bond. The blocks can be sawed by using a carbide blade to fit different sizes and shapes required in the construction of the house. They can be nailed into to support furring strips if one chooses to use drywall, or grooved with a router for insertion of electric tubing into that wall. Another unique aspect of an Earthblock house is the amount of insulation it provides. An Earthblock has an R factor of 44, which is higher than most other building materials. With a minimal amount of energy, an Earthblock house can be warmed or cooled. Other advantages are that the blocks are fireproof, termite-proof, noise-suppressing, and can withstand winds up to 200 miles per hour when built with a tie beam. Another important factor is Earthblocks are environmentally friendly and can be recycled back into the environment. With wood becoming scarcer and more expensive, Earthblocks offer one of the best alternative building materials for the future. Earthblock International is in the process of designing a block stacking machine. This automated unit will erect vertical walls as quickly as blocks can be delivered. This unit will cut the construction time for erecting walls by 30%. In this house, we are using metal lintels to support our window frames and door jambs. However, wood or precast concrete beams can be substituted and work as well. In earthquake-prone areas of the world, a tie beam is mandatory for an earthblock house. In addition to a tie beam, it is advisable to wrap the exterior walls of the house with chicken wire. The chicken wire can be stapled or nailed right to the surface of the blocks. Unlike rigid walls made of concrete, which tend to crumble during and after an earthquake, an earthblock house wrapped with chicken wire allows for slight movement of those blocks. This, in many instances, keeps the walls from tumbling during an earthquake or an aftershock. Support panels have been installed in order to pour the tie beam. We are using number 6 rebar to stabilize the tie beam, which will be 6 inches thick and 12 inches wide. The tie beam is poured right on top of the earth blocks. Truss anchors are embedded into the concrete in order to secure the roof trusses. Also, concrete columns are poured to lock the tie beams to the foundation slab. Here we see the tie beam, which adds additional stability to the blocks, connected to the foundation slab by poured concrete columns. In emerging nations, the columns can be replaced by rebar, which would be vertically embedded in both the slab and the tie beam, respectively. This house is being built with a hip roof using wood trusses. However, Earthblock International has developed a proprietary one-step metal roofing ceiling truss. The top of the truss, which supports the roofing panel, is a T. The bottom of the truss, which is a reversed T, is the support for a drop ceiling. This truss is attached onto vertical bolts which are embedded into the tie beam. 30-weight roofing paper is being attached to the plywood panels. However, Earthblock International has also developed a one-step roofing panel which does not require conventional roof coverings. This panel is made by coating plywood and other types of panels with a proprietary material called Ginzite. Ginzite is 100% waterproof, and once applied to a panel, it is virtually impossible to be sheared off. Asphalt shingles are being attached to the roof by nailing them on top of the 30-weight paper. This is a proven technology which has been successfully used in the United States for the last 100 years. However, in poorer nations, where millions of houses are needed, less expensive roofs and roof coverings can be used on earthblock houses. Brushing the earth blocks with a stiff brush dislodges any loose debris and gives the walls a smoother finish. This allows for better adhesion of the coating materials to be applied to the surface of the block. In the case of this house, we are using stucco for the exterior finish. However, Earthblock International also uses Ginzite to seal and coat the blocks. The Ginzite can be sprayed, painted, or rolled onto the surface. By tinting the Ginzite, it waterproofs, paints, and coats the blocks in one easy application. Now that the stucco work has been completed and the house is ready to be painted, here is the construction data. It took 80 man-hours of unskilled labor and approximately 4,300 earth blocks to build the shell of this 950 square foot house. To build the shell of a 500 square foot house would require approximately 48 man-hours of unskilled labor. Now, you are seeing what a well-built earth block house can look like. In looks and structure, it can compare with any other house in the marketplace. In cost, few, if any other houses can compete with it. According to UN figures, 450 million low-cost houses are needed worldwide. By the year 2025, another 600 million low-cost houses will be needed. That's over 1 billion new homes. Wood is not the answer. That would deplete most of the forest left in the world. With Earthblock International's advanced technology, we are confident we have one of the key solutions for low-cost housing worldwide.